good? I think, is it good? Yeah, it's good. Yeah, 3:30. Good afternoon. A bit of housekeeping. If you were to go onto your content on Avenue to Learn, and if you were to go into your homework, and if you were to click on homework 03, okay, so this is homework 03. I did not make any mistake by posting the solution and the homework at the same time. I repeat again, this is not a mistake. This is deliberate. I repeat again, this is deliberate. So I want you to, next week, Monday, what do we have? Yeah, term test, right? So I hope this will help you revise and study. I appreciate some students telling me, Eugene, you make a boo-boo by posting both of them at the same time. No, I deliberately do this. So when you attempt your homework, okay, don't look at the solution first. Are we clear? Try on your own first and see, does it make sense? Okay, don't focus on the solution and then, oh, it's doing this, it's doing that. Have not learned this before. Yeah, you have not learned this before because I've not taught you yet. Are we clear? Okay, so if you look at the homework from question 4 onwards, you have not learned it yet. Okay, so don't beat yourself up if you don't know how to do. Okay, it's not your fault, it's my fault for now. Okay, by Thursday, you should be able to attend all the questions. Are we clear? Okay, Friday, again, there'll be a 2 hours tutorial. You have any questions, come and see me in ITB 137 from 4:30 to 6:20. My life is yours. If you want me to do question number 1 to the last question, we do it. Are we clear? Okay, so I don't want you to like start panicking or whatsoever. You should not panic yet. Okay, right. So we are going to look at the rigid body planar motion, and on Friday last week we stopped to angular velocity. Okay, we stopped to angular velocity. Is it angular velocity? No, we stopped. Sorry, we stopped at, yeah, angular velocity. So one thing to highlight over here, right? This is not times. This is cross. We are going to do vector multiplication later on. Okay. Right. So today we're going to continue the lecture from here. And there's images that you guys should have. And all these, yeah, you should have all these images on Avenue to Learn. Did I post them? Can you see the images or no? Did I post them for you? I don't want to say something and I have not done it yet. Let me check. Okay, so we go to content, you go to lecture. Oh, not yet. I do apologize. Oh, doing 10 things at one time. Okay, so if you would open on Avenue to Learn, these are all the images that I'll be using for this week. Okay, so I hope you all can you all check if it's available for you all to access, please? We are good. Right. Sincerely apologize for that mistake earlier. So the next thing we are going to talk about are 2 things. Okay, so we're going to be fixated on this diagram over here. So as you can see, the diagram is when what does this diagram actually mean? I was quite worried that I did not explain, and it's my fault last Friday. Over here is what we have known as a rigid body. Okay, a rigid body, and then we have a point P, and I want to draw attention to you that we have AT, AN, and a solution. The entire body is rotating about axis down here, is which we like to call it an instantaneous axis. Okay, it's an instantaneous axis, i.e. the velocity on this axis is equal to what? 0. Okay, so that is it. So now if we were to focus on acceleration, let me see the acceleration, how much. Okay, if we were to look into angular acceleration, okay, if we look at the formula for angular acceleration, we know that alpha is equal to d omega over dt, okay, where alpha is the angular acceleration. Okay. Before we go there, you have to also refer to this diagram. Okay, you also, I mean, it's not critical, but you have to refer to both diagrams when I'm teaching. So it's the other diagram with the one with the thumb. Okay. Right. So alpha is the angular acceleration, and it can be also expressed. We know that omega is also equal to d theta over dt. Okay. So from here, we know that alpha can be written as d over dt, and then we have d theta over dt. So this will be d squared theta over dt squared. Okay, so we have the expression. So now if we look into equation, if we were to focus, note, right? Note, if we were to focus on the expression where we have omega is equal to d theta over dt, and we also have the expression where we have alpha is equal to d omega over dt, right? So if we look at, so I'm going to address this as equation number 1, and this as equation number 2. Oh, yeah, there's an equal sign missing. Thank you. Now, is my handwriting visible today? Are we okay? You all can see? Good. I try to slow down a bit and write properly, okay, better. So if you look at equation number 1, it's very obvious that dt is equal to d theta over omega. And then if we were to look into equation number 2, we know that dt is also equal to d omega over alpha. So from here, we equate equation 1a and equation 1b, 2a. Okay. So what we have is d theta over omega is equal to d omega over alpha. So in this context, we have a new expression where the angular acceleration d theta is equal to the angular velocity d omega. Any questions so far? Okay, let's look at one example. Okay. So we are going to look at example number 1. There are a lot of theory they have to go through, but I don't want to go through a bunch of theory and then we don't know what is going on. Let me go into some example because what I'm teaching is not that bad. It's not that difficult. Okay, so let's look at example number 1. And this is on Avenue to Learn. So this is our example number 1. Okay. When I look at a diagram like this or figure like this, I also get very confused. I repeat again, I get very confused. So it's okay. Okay, so the only way not to get confused is learn how to isolate the problem. Okay, so for a short time, gear A rotates with an angular acceleration is equal to alpha A is equal to 450 t squared. Okay, so we are given alpha A, which is equal to 450 t squared plus by 60 radians per second squared. Okay, so we know that this problem is not what? Constant what? Acceleration. Okay, so you cannot use the famous tree equation, yes or no? Right, you cannot use the famous tree equation. And t is in seconds. Determine the angular velocity and angular displacement of gear B. So we have to find, so we have to determine, right? We have to determine omega omega or theta B or omega B and theta B. Okay. At time is equal to 2 seconds. Okay. Starting from rest. Okay. So the radii or the radius of gear A, so RA, is equal to 0.01 meters. And RB is equal to 0.025 meters. Okay. So the first thing I want you all to do is to concentrate on the gear. Okay, concentrate. So this is the information that's given. It looks really, really messy over here, right? But the only thing that we have to be focused on is focus on this section over here. In this section over here, you have gear A and gear B. And I want you to have a habit to draw your transformation. I want you to have a habit. So I'm going to call this, okay, Z. Okay. So this is my X and this is my Y. Why I like to address Z in that axis because it's dependent on the rotation of the shaft. So the rotation on the rotation of the gears is in this axis, yes or no? Right? So it's common to address the Z-axis as the axis for angular rotation. Okay? If you don't want to use it, fine. The most important thing is you have to start drawing your what? Transformation. Regardless whether it's 2P, 2Q, 3A, you have to have the habit for doing that. Okay? Right. So from here, I'm going to draw. Remember, our paper is a 2D problem. Our paper is in 2D, okay? So we have to be able to visualize this in 2D, okay? So I will now start to construct our view where this is our X and this is our Y and this is our rotation about Z. So we like to look at gear A and gear B. Okay. So now I'm going to isolate the rest of the diagram that are just noise and just focus on 2 gears. Okay, just focus on 2 gears. So this is our gear A. And the next one I'm going to draw that I will deliberately draw it bigger. This is our gear B. Okay. So over here, we just need to label gear A. And then we label over here gear B. For now, this question looks for amplitude, so it's easier. Later on, we start looking for vectors, it gets more complicated. Okay, so we call the rotation over here omega A, and this is the center. We have another center over here. If omega A is in that direction, this is omega B. Okay. And exactly where you have the contact over here, okay, it's moving at a velocity v. Okay. Yeah, I'll call it v. Okay.